Good morning, students. My name is Dr. B. Suresh Babu, working as a professor in Mechanics Engineering Department in MGR College of Engineering and Technology, Paritala. As a part of online classes, today's my presentation is on balancing of masses. Balancing of masses. The main aim of this class is why we need balancing, what are the different types of balancing has to be done, and a analytical method to solve a unbalanced mass. I repeat once again, only three important. First one is why we need a balancing. Second one, in what cases we need balancing. And third one is what are the parameters that can be found for balancing a system. So these are the three important things to address in this class. So to pay attention, students, what is balancing? Often an unbalanced of forces is produced in rotary or reciprocating machinery due to the inertia forces associated with the moving masses. So what is the first thing which you observe here? The unbalance of forces produced in rotary and or reciprocating machinery. There are number of rotary machines are there and reciprocatory machines are there. Rotary machine means a wheel is a rotary machine. There is a crank mechanism. We have a rotary machine as well as a reciprocating part. To balance that rotary or reciprocating part, we should go for balancing. So first thing is any dynamic system, we need a balancing to continue its operations for a longer period of time. In the first class, I taught the precautions, importance of this balancing. In the class, I explained already why we should go for balancing. So it is observed that balancing is needed for rotary parts and reciprocating parts. In rotary also there may be number of rotary parts, and reciprocating also there are number of reciprocating parts. So the first thing to remember. Second one is balancing is the process of designing or modifying machinery so that the unbalance is reduced to an acceptable level and if possible is eliminated entirely. So balancing is the process of designing or modifying machinery so that the unbalance is reduced to an acceptable level and if possible is eliminated entirely. What is the meaning here is to balance a system, we should modify a design if it is unbalanced. At the same time, to balance the system, we are designing or modifying the existing system so that we can eliminate the unwanted parameters that are present in the system so that it can improve or the functioning can be improved to a large extent. So these are the 2 points from this slide. The balancing should be done for rotary parts or as well as for reciprocating parts. Once again, there are number of rotary parts are there. There are number of reciprocating parts are there based upon the volume of the system. If you take a gear wheel or gearbox of a lorry, bus or a car, there are number of rotating gear wheels will be there. So we need some mathematical solution to bring that balance system. If you take a cycle rear wheel, you have only one sprocket will be there. So that is one rotating bar on a shaft. Like that in the reciprocating system, if you take a spider crank mechanism, spider is going to be moving and a crank wheel is going rotating. Shaft, one crank wheel will be there in the cylinder, one rotating part will, one reciprocating part will be there. So that can also be balanced. So this is the examples of that one. And we need to balance a system means we have to modify existing system or we have to redesign a system so that we can reduce the unwanted parameters in the system to run in an efficient manner. That is the first thing to be understand here. Next, as I already told, this is the one example to emphasize for single rotating system. A particle or mass moving in a circular path experiences a centripetal acceleration and the force is required to produce it. An equal and opposite force acting radially outwards acts on the axis of rotation and is known as centrifugal force. So, if you observe these two parts, if any object is rotating on an axis, it's try to expel from its axis. That means an equal and opposite force acting radially outwards acts on the axis of rotation and is known as centrifugal force. That means a force that is acting towards the center is called as a centripetal force. A force that is acting away from the center is going to be called a centrifugal force. So to bind that shaft to have the system in existing manner for longer period of time, shaft is fixed in a rigid manner. On the shaft, wheel is going to be rotated. So this expelling force is compensated by the force that is fixed to the shaft. That means shaft is rigidly fixed so that it can rotate a number of times for a particular speed. Its speed goes on increasing and load is going to be goes on increasing on the shaft. At one point of time, it is going to be fail. So to eradicate the fail, you have to go for a system that is increasing the mass of a shaft or increasing dimensions of a shaft or reducing the parameters on the load so that we can bring the system in a stable condition for longer period of time for a particular speed. So that is the thing to be understand here first. So a particular mass is moving in a circular path, experiences centrifugal acceleration, and the force is required to produce it. An equal and opposite force acting radially outward acts on the axis of rotation and is known as a centrifugal force. This is a distributing force. This is a disturbing force on the axis of rotation, the magnitude of which is constant, but the direction changes with the rotation of the mass. So second parameter is when it is going to be take a rotation, it is in clockwise rotation or anti-clockwise direction. Two directions are possible. So it is fixedly. Otherwise, the mass can move in different directions on the same axis also. So the disturbing force on the axis of rotation, the magnitude of which is constant, but the direction change with the rotation of the mass. In the revolving rotor, the centrifugal force remains balanced as long as the center of the mass of the rotor lies on the axis of the shaft. In a revolving rotor, the centrifugal force remains balanced as long as the center of the mass of the rotor lies on the axis of the shaft. When the center of mass does not lie on the axis or there is an eccentricity, an unbalanced force is produced. So it is clearly mentioned in the second point. When unbalanced force is produced, When the center of the mass does not lie on the axis or there is an eccentricity, due to that one, an unbalanced force is going to be produced. That means if it is at the center, it can go for a number of working cycles. If it is not at the center, that is, it is at eccentricity. Sorry. It leads to the different types of unbalanced conditions. Those unbalanced conditions can be brought to balanced condition by redesigning or by modifying this one. So we have, by this slide, we have observed totally 4 points. First point is with the rotation, centrifugal force is going to be produced on the shaft. To make it into stable condition, shaft is rigidly fixed. Next, the quantity, magnitude is going to be same, but orientation is also affect the unbalanced state of the system. Third one, change in position of a disc or rotary object on a shaft are also leads to unbalanced state. So to bring it to balanced state, there are three opportunities are there. So one is balancing with the help of a direction, balancing with the help of a magnitude, balancing with the help of a position. So these are the three things. If you observe this diagram, a shaft is there, omega is angular speed, mr, this is the mass that is acted here, r is the radius from the center to this one. So by this we are going to find the magnitude of this mass while the object is going to be rotating. So this is the shaft. Here to the shaft we have coupled and another disc. Disc is also a process that a mass will be there and disc center E will be there. That is eccentricity. That means it is not at the center means it may be varying from here. And this is another one. So this is the first one. To this one we have fixed a mass with the help of a disc. The disc may be irregular means once again it may be a unbalanced condition for this system. Irregularity has to be brought to regularity by adding masses to the disk or by adding another mass on the disk. That is another condition. Like this, number of conditions will going to be present for a system. Why balancing is necessary? The high speed of engines and other machines is a common phenomenon nowadays. It is therefore very essential that all the rotating and reciprocating parts should be completely balanced as far as possible. If these parts are not properly balanced, the dynamic forces are set up. These forces not only increase the loads on bearings and stresses in the various members, but also produce unpleasant and even dangerous vibrations. Nowadays, everyone know that the high-speed engines are utilized for automobiles. For bike also, we preferring high-speed engines for a car, lorry, jeep to have a quick transport from one point to another point. It is everyone is preferring high-speed engines only. So a stable object has certain dimensions to balance it. Same object, if it is used in dynamic state, some another constraint has to be considered to be in balanced state. That's why so balancing a dynamic state is very difficult than compared to a static. If you take engines, automobiles, aeroplanes, ships, extra care has to be taken by because these are in dynamic state. The on that one, number of other parameters are also acting on that one. It is therefore very essential that all the rotating and reciprocating parts should be completely balanced as far as possible. So we have to balance rotating parts as well as rotating reciprocating parts. If these are not balanced, it leads to the vibrations. As already I told in the beginning of the previous class, vibrations will be there, noise is going to come, wear and tear is going to be large, it produces vibrations, and it leads to the failure of the total system. Day by day, the efficiency will increase, and in less period only, the system is going to fail. To eradicate all this one, we need a balancing system. Balancing of rotating masses. Whenever a certain mass is attached to a rotating shaft, it exerts some centrifugal force, whose effect is to be bend the shaft and to produce vibrations in it. In the beginning of this class, when I told one a diagram, a shaft will be there. On the shaft, we are going to fix a disc. His mass is fixed. Due to that mass, shaft is going to be bent. If it is going to make rotation, still vulgarity will be there in bending. So that system is one of the example that we can explain for a dynamic state. If it is stable means no problem, but if it is going to be a imbalanced state in dynamic means you should take extra care to be in balanced condition. In order to prevent the effect of centrifugal force, another mass is attached to the opposite side of the shaft at such a position so as to balance the effect of the centrifugal force of the first mass. In order to prevent the effect of centrifugal force, another mass is attached to the opposite side of the shaft at such a position so as to balance the effect of the centrifugal force of the first mass. This is done in such a way that the centrifugal force of both the masses are made to be equal and opposite. This is done in such a way that the centrifugal force of both the masses are made to be equal and opposite. The process of providing second mass in order to counteract the effect of centrifugal force of the first mass is called balancing of rotating masses. So I have defined clearly what is the definition of this balancing of rotating masses by this side. What this one? The process of providing a second mass in order to balance the system that is acting already on the shaft is, that is on the first mass, is going to be called as a balancing of the masses. So with the centrifugal force, the unbalanced state is going to be created for a shaft and a disc assembly. To eradicate that one, to remove that one, we are going to add a counter mass in opposite direction. It may be a large mass or a small mass. The position has also differed. Here it is exactly opposite that one we are saying. If you observe the one example already I told, it may be regulating the distance R also. R may be varied and M quantity is also can be changed. We have a large M and small r, or large R with small m, because it can counterpart the first mass magnitude and its R position. So I think I am clear with this one. First one is by adding another mass in opposite direction, we can able to bring a first unbalanced rotating mass into balanced mass. For this one, the parameter is mass, position of second mass, and distance from the shaft to the mass. So this is the parameter which we can understand. Next. So first part we have concluded. What is the aim? What is the aim of the class? Already I told. The aim of the class is why we need balancing, how to do balancing. That part is over. So why we need balance, how we balance the rotating mass we have discussed. Now, what are the different types of possibilities or cases that are possible for balancing of rotating masses? If you observe, the following cases are important from the subject point of view. Balancing of a single rotating mass by a single mass rotating in the same plane. So, balancing a single rotating mass by a single mass rotating in the same plane. Balancing of a single rotating mass by two masses rotating in different planes. That's the second condition. Balancing of different masses rotating in the same plane. Balancing of different masses rotating in different planes. These are the four possible conditions or methods that we can go for a balancing a system. I repeat once again, single rotating mass in a single on the same plane, single rotating mass by two masses rotating in different planes, balancing different masses rotating in the same plane, balancing different masses rotating in the different planes. Next, balance first condition I am explaining to you. Balancing of a single rotating mass by a single mass rotating in the same plane. So, as we are considering rotating as one condition, as rotating will be there, reciprocating will be there. Consider a distribution of mass m1 attached to a shaft rotating at the speed, that is angular velocity radians per second, as shown in the figure. Let r1 be the radius of rotation of the mass m1. R1 is means distance from the axis of the rotating of the shaft and the center of gravity of the mass m1. That means if this is the center of m1 mass, from here the distance is going to be called as the r1. So this is the r1. So to bring this state into balanced condition, we can add another mass, that is m2. The distance is going to be r2. So we know that centrifugal force exerted by the mass m1 on the shaft is equal to Fc1 is equal to m1 omega into r1. So centrifugal force is nothing but a product of mass m1, speed and r1. How many parameters are there? The third point we are discussing, parameters that we can find to bring a unbalanced mass into a balanced mass. That is m into omega square into r1. The centrifugal force acts radially outwards and that produces bending moment on the shaft. The centrifugal force acts radially outwards and that produces bending moment on the shaft. In order to counteract the effect of this force, a balanced mass m2 may be attached in the same plane of rotation, so that distribution mass m1 such that the centrifugal forces due to the two masses are equal and opposite, such that the centrifugal forces due to the two masses are equal and opposite. So if you observe this system, this is axis of rotation and this is r1 distance from the center of the first mass to the axis distance, and r2 is distance from the mass m2 to the axis of rotation. So this is how we can define. How many parameters are there? Mass is there, speed is there, distance from the center of axis of rotation to the mass m. So these are the three. For what condition? For single mass, single rotating in the same plane. So if you observe this one, R2 is the radius of rotation of the balancing mass M2 and distance between the axis of rotation of the shaft and the center of gravity is m2. Therefore, centrifugal force due to the mass m2 is equal to Fct is equal to m2 into omega square into r2. So this is the speed of second mass omega square. R2 is the distance, M2 is the mass. As the speed is constant because it is rotating on the same axis, so angular speed is going to be constant. The parameters here will be M2 and V2 R2. Why? Because these two are rotating on the same plane. That's why the speed is going to be constant. Then finding the equations from 1 and 2, M omega square R1, M2 omega square R2. As angular velocities are constant, the parameters are M1 R1, M2 R2. If M1 and R1 are known and M2 is unknown and R2 is known, then M2 can be calculated to bring the system into balanced state. For example, R2 is a constant, M2 is known, and R2 has to be varied, means then the distance is going to be found because M1 R1 is a first balancing state. So, for example, this is 100 kgs. To bring this into 100 kgs, we can vary M2 and R2. If one is known, one is fixed, remaining R2 can be adding parameter. If R2 is known and M2 can be added to bring this into 100. Thereby, the unbalanced system can be brought into a balanced system. The product of M2 R2 may be split up in any convenient way, but the radius of rotation of the balancing mass M2 is generally made large in order to reduce the balancing of mass M2. Second, the centrifugal forces are proportional to the product of the mass and radius of rotation of the respective masses because omega square is same for each mass. Why? Because they are on the same rotation. So we can have a large mass with small r2. This type of function, or we can have a small r2 and a large m2, or small m2 with a large r. Proportionally, if you observe this note point, preferably large mass with small r have a less vibrations. So this is the third key point. So parameters we found. The parameters is mass and R. Next, balancing of a single rotating mass by a two masses rotating in a different planes. In the previous arrangement, the balancing gives rise to a couple which tend to rock the shaft in its bearings. Therefore, in order to put the system in complete balance, two balancing masses are placed in two different planes, parallel to the plane of rotation of the disturbance mass in such a way that they satisfy the following two conditions of equilibrium. The net dynamic force acting on the shaft is equal to 0. This requires that the line of action of three centrifugal forces must be the same. In other words, the center of the masses of the system must lie on the axis of rotation. The center of the masses of the system must lie on the axis of rotation. This is the condition for static balancing. The net couple with the dynamic forces acting on the shaft is equal to 0. In other words, the algebraic sum of the moments about any point in the plane must be 0. So static balancing means the net dynamic force acting on the shaft is equal to 0. The line of action of three centrifugal forces must be the same. That's the static balancing. In dynamic balancing, first and 2 points has to be satisfied. Why? Because as the forces are going to be vary in the dynamic state. The balancing of single rotating masses by two masses rotating in different planes. The following two possibilities may arise while attaching the two balancing masses. The plane of distributing masses may be in between the planes of the two balancing masses. That means the plane of distributing masses may be in between the planes of the two balancing masses. Okay. the plane of distributing masses may lie on the left or right of the two planes containing the balancing masses. So that means if you observe a shaft is there, on the shaft, if this is the first position, exactly opposite we are going to act. This is the one mass acting in counter direction. In second case, this is the first position means another two position means here may be one and this side it may be left side, it may be right side. That is the second, that is the different planes. That is the thing to be understand here. So these are the two possibilities to bring one mass with two different masses. It may be left side or it may be a right side. Next, when balance distribution glasses, when the balance of distribution lies in between the planes of two balancing masses. So that's what we can observe here. Here mass is there, it is acting like this, and to balance this one, we have another mass m1 and this is m2. Here the r will be another parameter varying. Here another parameter r may be different from here for m1 case and m2 case. And from the m, the L1, L2 may not be equal or may be equal to bring m mass into a balanced state. So if you observe this one, plane distributing mass lies in between the planes of the two balancing masses. Consider distribution of mass m lying in the plane A to be balanced by two rotating masses m1 and m2 lying in two different planes L and m. So this is the, in first case, here directly m is there, we have counter added here. But in this case, to balance this m, we are using m2 here and m2 here. As already I told in the diagram, this is the condition. It should be balanced. That one, we can add an element here. This is one type of thing. One mass with one counter mass on different plane. Here, second case, one mass is there. To balance this one, we can add two masses in two different planes. Here R may be varying, L may be varying. So L1 is the distance between the planes A and L. L2 is the distance between the planes A and M. And L is the distance between the planes L and M. I think you can observe the diagram. By this diagram, we can have a how L2, L1, L, R1, R2. Here R are not shown, but the same thing we can represent it in another view. This is the M from the center to R. This is M2 in R2 distance. M1 is about R1 distance. Like this, it will vary. Here the parameters are L may be the one parameter, R may be the parameter, and M is another parameter. So by treating this condition, if L is going to be one parameter, we know the centrifugal force exerted by the mass M on the plane A. This is in the previous diagram we represented the same thing. Similarly, the centrifugal force exerted by the mass m1 in the plane L is m into omega square into r1. At the same axis of on the axis only, m is there, m2 and m1 and m2 are there. So speed is going to be common. That is, angular velocity is going to be common. The centrifugal force exerted by the mass m2 in the plane m. Ft2 is equal to m2 into omega into r2. Since the net force acting on the shaft is equal to 0, therefore centrifugal force on distributing mass must be equal to the sum of the centrifugal forces on the balancing masses. So Fc is equal to Fc1 plus Fc2. So m omega square r is equal to m1 omega square plus r1 plus m2 omega square into r2. Now, in order to find the magnitude of a balancing force in the plane L, The dynamic force of the bearing Q of a shaft, the moments about P, which is the point of intersection of the plane M and the axis of rotation. Therefore, Fc1 is equal to L is equal to Fc into L2. Once again, Fc is M1 omega square R1 into L is equal to M omega square R2 into L2. So M1 as omega, wherever is common for all the masses, by cancelling those two, the parameters left are M1 R1 L1 is equal to M R L2. MR M1 R1 is equal to M into R into L2 by L1. So if you observe this one, by using this wait a minute students. So similarly, in order to bring this one into balanced state, try to understand. We are going to use M1 R1. So M2 omega 2 R2 into L. Like M1 is there, here we can go for M2 mass. M2 into R2 into L into M into R into L1. So M2 R2 is equal to and L1 by L1. It will be noted that first represents the condition for static balancing. But in order to achieve dynamic balancing, equation 2 or 3 must be satisfied. Because by adding M2 mass, it may be reducing the first balanced condition. By adding M1, still we can be able to come into balanced state. So if you observe the present explanation, at the beginning I have given three aims to you. First aim is why we should go for a balancing and what is the definition of a balancing. What is the first one? Balancing has to be done to reduce vibrations, to increase the life, to reduce wear and tear, to improve smoothness. Next, second one is what are the areas which we go for balancing. The balancing can be done for rotating masses and can be done for reciprocating masses also. Next, where we should go for this balancing. Second aim, for that one, the classification is there. One mass, same plane. One mass, two different masses on the same plane. Or different masses on the same plane, different masses on the different planes. Next, another third aim I told is third aim of the class is what are the parameters that is available for a balancing. What are the parameters? The parameters are mass will be there, radius of rotation will be there, length will be there from a one mass to another mass. So these are the three ones. As the speed is constant, that is not considered because all are rotating on the same axis. So this is another parameter. See students, as per the timetable, here tutorial class is also there. The tutorial link I will give in the WhatsApp through WhatsApp. And for third year at 1 o'clock we have another lab session is there. For lab session also I will give the link and all of you participate through that link for online class lab. Those who are in coming to college tomorrow, they can directly have the lab and the same thing will be explained to you by showing the demonstration of the equipment. I repeat once again, this class, today's class is for two parts. One is for the online offline class. Second one is about tutorial. In that some tutorial, I will give a separate link. You join with that link. At the time I will mention, it is 11 as per the timetable. So I think you understand. For third year sessions, Dom and Tom will be there. Tom lab will be link will be shared at 1 o'clock. So by this, I am going to conclude. The complete notes is available in Google Classroom course 4FW5XCC. All are small letters. Or you can go for our department link and go for third year subjects. In third year subjects, once again, go for a DOM subject and you can have the fourth link. By this, today's class is going to be concluded. You all students, if you have any clarifications are there, you can mail to me, cpi@reddishmail.com. Thank you students. See you all. Bye. Have a good day.